This is lesson 8.2. We're going to be studying the sine law. The sine law is another trig formula that you can apply in a different situation. So our learning goal is to apply the sine law in acute triangles. So what does this all mean? Well, first of all, acute triangle is a triangle where all the angles are less than 90. They still all add up to 180, but they're all less than 90 degrees. So for example, 60, 60, 60. We've been dealing with in chapter 4 right angle triangles. And when you have right angle triangles and you want to solve them, you can use SOH, CAH, TOA. So you could use the ratios, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. That works, these all work, but they only work for these right angle type of triangles. Not all triangles are right angle triangles. And if you were to say, well, we gave up after that when we saw different types of triangles, you'd be wrong, because we came up with other rules and formulas that employ these trig functions. And so here we have the sine law. We're going to focus on triangles that are acute triangles. Again, like I said, angles are less than 90. These rules will work when we're dealing with basically obtuse triangles as well. But we're going to focus primarily on acute triangles. So obtuse triangles would be where you have, so I'm just going to write that down, obtuse, where you have one angle that's greater than 90, and then the rest are less than 90, but they all still add up to 180. If you have basically a non-right angle triangle, is called oblique. So oblique would be non-right angle. And then of that you have acute, which means everything is less than 90. And then you could have obtuse, which means that which means that one is more than 90. So you have one angle that's more than 90, and then the rest are less than 90. And again, we're going to be focusing on acute triangles for the most part of grade 10. We will see an example with obtuse, but that's what we'll be focusing on primarily. So the sine law, we're going to use it when long story short, we're going to use it when we don't have a right angle triangle. If you have a right angle triangle, use these here. If you don't have a right angle triangle, then you can use the sine law or another law we'll learn in the next lesson called the cosine law. And it all depends on what information you have. So when you look at the information you're given, you're going to figure out, should I use the sine law? Should I use a cosine law? Your first question now is going forward is going to be, is it a right angle triangle or not? If it's right angle, you're going to use this. If it's not, you're going to choose the sine law or cosine law. In this lesson, we're focusing on sine law, so we won't have to see if we're using cosine law for now. So this is more of an exploratory part. You're going to be labeling this triangle and measuring angles and sides using a ruler and protractor. You do have to be specific and accurate with this, otherwise you're not going to get the answers we're really looking for. To demonstrate this, it really relies on your specificity. We're going to try to demonstrate the sine law. First, we're going to label the triangle. We want to label the largest angle A, so the vertex over here would be A. This looks like the largest angle. If you weren't sure and you couldn't visually tell, you could measure it and you would see this would be the largest angle here. So this would be vertex A, which also has angle A in here. This would be angle A. Basically, the angle is named after the vertex that it's named after, the vertex it's attached to there. Then the smallest angle would be C, and that looks like this for sure. That would be the smallest angle over here, angle C, vertex C. And then we have B remaining over here. So this is triangle. This would be called triangle A, B, C. So A, B, C. And we want to label the sides. So usually when you name a triangle, you name it based on its vertices. So triangle ABC. And when you label the sides, you label the sides based on the angle opposite to them. So for example, this is vertex B, angle B. Inside is angle B over here. The side opposite to it would be called side B, but with a lowercase letter. This is vertex A with angle A there. The side opposite to it would be, well, side A with the lowercase a. This is vertex C, angle C. The side opposite to it would be side C, but lowercase c. So when you print this out, you're going to be asked to measure the sides with a ruler and the angles with a protractor. And I'm going to give you some general answers you should get if you're measuring things properly. So I believe for side A, you would get about 8.5 centimeters. And if you were to measure angle A, this angle over here, so side A you get 8.5, angle A you would get about 97 degrees. So it's not 90 degrees anymore, it's larger than 90 degrees. So we're dealing with an obtuse triangle. Like I said, we're going to be mostly dealing with acute, but we have an example of an obtuse here. No big deal, it still works out. For side B, you'll get about 7 centimeters, and the angle will be about 55 degrees. For side C, and let's put 7.0 because I'm estimating here, and I was able to see about 7.0. For side C, you get about 4 centimeters, and the angle is about 28 degrees. So now what we're going to do is we're going to go find these ratios here. There's some ratios. They look kind of random, but you'll see they're not. They're there for a reason. So we're going to do side A, 8.5, divided by sine of angle A, sine of 97. And if you put that in your calculator, so 8.5 divided by sine of 97, you get about 8.56. So I'm going to round the 2 decimal places, 8.56. We'll do the same thing for B. So we'll do 7 over sine of angle B. And we get, so 7 divided by sine of 55, about 8.55. And then we'll do the same thing for C. So C was 4 divided by sine of 28. And we get about 8.52. So what you'll notice is these ratios are all very similar to each other. The A over sine A is very similar to B over sine B, and very similar to C over sine C. They're actually equal to each other. The differences we see are because of errors in our measurement that we took with our rulers and protractors. If you're a bit more accurate than I was, you'd see much closer results. So they are actually equal to each other. That is what the sine law is. It's the relationship between the sines of angles and the lengths of the opposite sides. That's what the sine law is. So again, we do the ratio between a side and the sine of its angle, the opposite angle. So the side and the sine of the opposite angle. The side and the sine of the opposite angle. They can actually all be equated to each other. So how do we write the sine law out? Well, you can write it like this. There's actually 2 ways to do it. So when the first way I'm going to write is this way here. So you can write A sine A. So the length of side A over the sine of angle A is equal to the length of side B over the sine of angle B, which is equal to the length of side C over the sine of angle C. And you're going to write it like this when you're looking for sides. So when you're looking for sides, you'll write it this way. You could also write it, because it's a ratio, or you could write it like this: sine of angle A over length of A is equal to sine of angle B over length of B is equal to sine of angle C over length of C. You can write it like this, but when you're going to do this only when you're looking for angles specifically. When you're looking for angles. So when you're looking for sides, write the sine law like this. When you're looking for angles, write it like this. And what I want you to get is that when you're solving a triangle and you're looking for sides or angles, you're only going to use 2 at a time. Meaning you're not going to write all 3 down at once. So for example, if I'm looking for side A and I know B, and I know information about B and A somewhere, I'm going to write it down like this. I'm going to put A sine A is equal to B sine B. And I'm going to leave the C out if I don't have any information about it. So basically I'm going to compare something I don't know to something I know, and only use two at once, not all three. That would make things way too complicated. You don't need to use all three. So when can you use the sine law? So to use the sine law, first of all, you need to know that it's for a non-right angle triangle, meaning oblique. And there's two possibilities here. One, if you know two sides and one angle opposite to one of those sides, then you can use the sine law. So two sides and one angle opposite to one of those sides. Or if you have two angles plus one side opposite one of those angles. So to use the sine law, first of all, it has to be a non-right angle triangle. In other words, if you have a non-right angle triangle, don't use SOHCAHTOA. It's not going to work. Only use SOHCAHTOA for right angle triangles. As soon as you have non-right angle, you need to use sine or cosine, but we're focusing on sine right now. How do you know if you're going to use sine? Well, do you have two sides and one angle that's opposite to one of those two sides? Doesn't matter which one, just at least one. So that way you can fill in your information in your formula. If you know two sides, so you know A and B, and you know angle A, now you're only looking for angle B. Or if you have two angles and one side opposite to those angles. So if I know A and B, and one side opposite, so let's say B, now I'm only looking for A. So you need to have basically three known factors that fit in this formula, and then you'll have one unknown, and you can solve for a triangle or a part of a triangle that way. It'll make a lot more sense once we actually do some examples together. So we're going to start off with one of the examples, and then we're going to continue in the next lesson since the video will be cut short. So let's go on to try example A over here. Use the sine law to find the missing length in each triangle. So first of all, I'm going to label my triangles. Notice how the missing length over here is lowercase b. So I'm going to call this part here uppercase B. And then it doesn't really matter what you name the other sides, but I'm going to call this over here vertex A. I could have called that C, but I'll call it A for now. And then this one C. So A, B, C. What matters is that you match these sides and angles correctly. So if the first one that was given to me, I had to match that correctly. That should work. And so I'm going to name these as well. So this would be side A. I don't really need to find that. I'm just going to find the one that they're asking me for. This I know would be side C. So let's see what we have here. We have two angles. And if you think about it, you actually have more than two angles. You can actually find this angle here. So usually what I do is I recommend before you do anything else, find the easy stuff. Find that angle in there. This would be angle A. So angle A would be equal to 180 minus 45 plus 52. So let's write that down. 180 minus 45 minus 52, and we get 83. 83 degrees. So can we use the sine law? Well, we do have a whole bunch of angles. We have an angle over here and an unknown side. We have an angle over here and a known side. So we basically have two angles and one side opposite of one of those angles. So we can use the sine law. And we're going to finish that in the next video.